Hello student, in the previous video I had explained about the colligative property, but it was not completed. Now I would like to explain more about it. Ready? Properties. First is lowering of vapor pressure. Lowering of vapor pressure. Second is elevation of boiling point. Third is depression of freezing point, and the fourth is osmotic pressure. These four are the colligative property of the solution. Colligative property means the property which depends according to the mass of the substance, mass of solute, mass of solute. It means that the quantity which dissolve in the solution, the property depend, and these are the four property which depends on the mass of the solute only. Okay, I had explained in the previous my video, that is lowering of vapor pressure, and I would like to explain now all these three topics. Okay. Elevation of boiling point. Point. Elevation of boiling point. Boiling point of the solution. Boiling point of the solution. Boiling point of the solution is the temperature at which the vapor pressure is equal to atmospheric pressure. Atmospheric pressure and the vapor pressure of the solution is at equilibrium position, that is called elevation of boiling point. Let us suppose it is a container in which a solution is kept and begin to heat it. What happens? The pressure will arises at the upward direction, while the atmospheric pressure is towards the downward direction. At particular condition, when it comes in the equilibrium, that is ideally, then the liquid arises towards it, is because the vapor pressure becomes more than that of the atmospheric pressure. It can be better understand by using the graphical method to calculate the boiling point. To better understand how to calculate the elevation of boiling point, let us consider a graph drawn between x-axis and y-axis. On x-axis taken as the temperature reading in Kelvin, and on y-axis reading of the vapor pressure. Vapor vapor pressure. The curve shown as solvent, and next curve is solution. Okay. Consider this is the reading of 180. One vapor press. This temperature is considered to be TB naught. This is TB, and the difference between this is elevation of boiling point, that is delta T. 1 atmospheric vapor pressure is taken to the dotted line, and this curve is so the solvent reading, and this curve is so the solution reading. Now, this difference between TB and TB naught is the reading of the elevation of boiling point. Means delta T is equal to TB minus TB naught. Is it clear? As it is colligative property. As it is colligative property, delta T is proportional to M, where M is molality, Now this proportional can be removed by taking a constant. Delta T is equal to Kb into M. This Kb is a constant, and it is called molar elevation constant. Kb molar constant. Molar elevation constant. You can see here the graph is clear. Now, by using elevation of boiling point, how to calculate the molar mass of solvent. Molar mass of solute by using elevation of boiling point. For this, we can use the formula delta T TB is equal to KB WB into 1000 by WA A into MD, where MB is the molar mass of solute. Let us suppose to transfer MB is equal to KB into WB into 1000 upon delta TB into WA. Okay, now by using this formula, note down, we can calculate the molar mass of the solute in case the elevation of boiling point is given. This is the important formula for the calculation of this. Note down, student. Now I will give you an example to solve how to solve the numerical of. Now the question is, the boiling point of pure water is 100 degree. Calculate the boiling point of the solution containing 0.6 gram of urea in 100 gram of water. Given Kb is equal to 0.52. How to solve this? Delta Tb is equal to Kb into Wb into 1000 upon Wa into Mb. At first, we have to calculate the molar mass of the compound urea. Do you know the formula of urea? Anyone? That is NH2 C double bond O NH2. Hydrogen 4 atom here. Carbon 1 C into 1 plus N into 2 plus H into 4 plus O into 1. 12 into 1 plus nitrogen. Nitrogen, the atomic mass of nitrogen is 14. 14 into 2 plus 1 into 4 plus 16 into 1. Now add together, we get 12 into 1 plus the atomic mass of nitrogen is 14, 14 into 2 plus hydrogen 1 into 4 plus oxygen 16, 16 into 1. The final calculation is by adding together, that is 60. I mean to say MB is equal to 60. MB is 60 and WB is equal to 0.6 gram, while WA is equal to 100 gram. Now put these value on this formula. Is it clear? Write down the question or not? Remain on the blackboard. kb is equal to 0.52 into wb that is 0.6 into 1000 divided by wa mass of water, that is 100 into mg I had calculated here, that is 60. Okay, now after calculation of this value we will get 0.052. Okay, now thus the boiling point of the solution, BP of solution, BP means boiling point of solution, is 100 plus 0.052, 100.052 Celsius. This is the boiling point of the solution. The next point is definition of freezing point. Okay, at first the definition. Freezing point is the temperature at which the solid and liquid have same vapor pressure. Freezing point is the temperature at which the solid and a liquid have the same vapor pressure. Now the question, how to determine the freezing point. Definition of freezing point is to be determined by using the graphically method. Same on the x-axis temperature on Kelvin, and on y-axis vapor pressure. This curve represents the value of solvent, and this curve represents the value of solution. Okay, the temperature, this is TF naught, and this point is TF. Okay, and the difference is delta TF. is equal to Tf not minus T T delta Tf is equal to Tf not minus T. Delta Tf is the deviation of freezing point and it is colligative property. It is colligative property. That is why delta Tf is proportional to M. What I had told you before, M represent the molarity. Molarity. Okay, now for this proportion can be moved by using a constant, that is Kf into M, where Kf is a constant, and it is called molar freezing point constant. Molar freezing point constant. You can see on the blackboard. This can be also used to calculate the molar mass of the delta Tf is equal to Kf into W B into 1000 upon WA into MB, or MB is equal to Kf into WB into 1000 by delta Tf into WA. By using this formula, we can calculate the molar mass of the solute. Molar mass of the solute. Let us consider a question for which calculate the freezing point of a solution containing 0.45 gram of glucose in 50 gram of water. This is the question, how to calculate the freezing point. At first, the formula is delta Tf is equal to Kf into Wb into 1000 divided by Wa into Mb. This is the formula which I write in the before way. So at first we have to calculate the molar mass of the given compound, that is glucose. Glucose, the formula of the glucose is C6H12O6. The atomic mass of carbon 612 into 6 plus 1 into 12 plus 16 into 6, that is 72 plus 12 plus 96. Just after adding 180, which is Mb. Mb. Mb is equal to 180. That is the molecular mass of glucose. Here, how to calculate the molecular mass of glucose? Note down. Delta T F is equal to Kf. Kf is the given constant, which is 1.86 into Wb. Wb is 0.45. 0.45 into 1000 divided by Wa. Wa means 50 gram of water. 50 into Mb. Mb you have calculated here, that is 180. After the calculation of these digit 0.093, and this temperature is subtracted from 273.000 minus 0.093. We will get here 7, that is 0, and this is 9, 2, 7, 2 degree Celsius. Okay, now this is the freezing point of the solution. Okay, 272.907. In the same way, and we have to calculate the molar mass of the solute. Molar mass of the solute. Now the next qualitative property, osmosis. It is defined as it is the phenomena of flow of solvent, flow of solvent, flow of solvent, those semi metal membrane from the pure solvent of the solution from higher concentration to the lower concentration level. The definition of the osmosis, it is the phenomena of flow of solvent through a semi-permeable membrane, also known as selectively permeable membrane, because it crosses the selective material only from the pure solvent of the solution from higher concentration level to the lower concentration level. This is the phenomena of osmosis. Now I would like to define osmotic pressure, that is colligative property. Osmotic pressure, it is defined as the excess pressure applied to a solution to prevent the osmosis. To prevent the osmosis, that is called osmotic pressure. Mathematically, it can be written as pi is equal to C into R into T, where pi is the osmotic pressure, C is the concentration, R that is molar gas constant, and T is the temperature. As you know, at the constant temperature, R and T will be constant, and this constant can be removed as to be here proportional to C. Means osmotic pressure is directly proportional to the concentration of the solution. It means that if the concentration will increases, the osmotic pressure will also increases. If the concentration decreases, I mean to say dilution increases, then osmotic pressure will also decreases. It is clear now. That is pi is equal to WB/RT upon V into NV. By using this formula, we can calculate the molar mass of the solid if the osmotic pressure is given. Let us consider an example which I would like to solve here. Write down the formula now. Question is at 298 Kelvin, 0.1 liter of a solution containing 3.02 gram of unknown solute of osmotic pressure 2.55 atm. Now, what is the molar mass of the solute? As we know the formula, pi is equal to WB/R into T upon V into V into MB. Thus, MB is equal to WBR into T upon V into pi. Put the value MB is equal to WB. WB, that is 3.02. 3.02 into R. Molar gas constant, that is 0.082 into temperature that is 298. 298 upon volume. Volume of the solution is 0.1 into pi. Osmotic pressure 2.5. 2.55. Thus, MB, molar mass of solute, can be calculated. And just after calculation, let us start to do the calculation. I will not write here until you have not done. Okay, done. 289.7. 289.7. Just after the calculation of these digits, you will get the answer. This is the molar mass of the unknown solute. Okay, now is it clear? So I would like to repeat the summary of this concept. Colligative property. There are 4 colligative properties. First is lowering of vapor pressure. The second is elevation of boiling point, and the third is decreasing of freezing point, and the fourth and final is osmotic pressure. Now you can distinguish between osmosis and diffusion. Osmosis, semi-permeable membrane is essential. Semi-permeable. Is osmosis and diffusion. For the osmosis process, semi-permeable membrane is essential. Not is needed. No semi-permeable membrane is needed for diffusion. First point. The second point, it takes place in liquid state only. It can take place in liquid as well as gas. Also, diffusion can take place in liquid as well as in gas also, but osmosis takes place in liquid only. Okay. These are the 2 points to distinguish between osmosis and diffusion. Now the Van Helmont factor. Van Helmont factor, which is represented as I. I is equal to observed colligative property to the real value of the ratio of the observed colligative property to the real value of the colligative property is called Van Helmont factor. Okay. Now degree of dissociation. Degree of dissociation. It is defined as the number of moles dissociated to the total number of moles of